Assalamualaikum warahmatullahi wabarakatuh. Hi, hello, my name is Laili Azizah, and I'm from Chemistry Class A, Faculty of Science and Technology. In this opportunity, I will explain about aeration, review wastewater treatment, coagulation, and flocculation. Okay, so here we go. Table of content. The first, we will talk about what is aeration, and second, we will talk about the example of aeration. Okay, on this slide, we are gonna talk about what is the aeration. So, aeration is the process of contacting water with oxygen because oxygen molecules are reactive. And do you know that the oxygen included in sixth period of the periodic table? Okay, next, example of aeration. An example of natural aeration that exists in nature is the torrential flow of river water that form froth of water, while an example of an artificial aeration is an aquarium aeration. Okay, the function of an aerator to add the amount of dissolved oxygen. Aeration can also help ions to oxidize. See water which contain with ions. When ions contacting with oxygen, then oxygen will enter to the water. Because of that, it's very useful for marine biota. If in the aeration industry, the aeration tank uses a blower. It is related to the WWTP system or wastewater treatment. So for another example, a coral rock on the beach that are hit by the waves will not be eroded. Instead, the coral rock will be stronger than before because the waves will carry and attack a new layers to the coral rock. So next, the surface of a wall that is crusted by exposure to water. So right now, we will review wastewater treatment. Okay, take a sample of dirty water in urban areas, then divide it into two sample solutions. Solution A is 8 with alum, while solution B is 8 nothing. Sample solution A turns more clear after half mixed with alum and filtration process. Okay, so the following is the way alum works. In the colloid system always happens the molecule refuse each other. As they add with coagulant, the system changes to attract each other. When the system attract each other, it can meet a layer that we call as double layer. Okay, so in this below is step of drinking water treatment. First, screening. Second, coagulation, flocculation. Third, clarification or sedimentation. The last process is filtration. For the next is coagulation-flocculation. Coagulation is the addition of chemical to destabilize the electrostatic force of non-settable solids. Coagulant chemicals typically have a positive charge which bind to negatively charged particles in water, neutralizing them and allowing them to come together to form small clumps of particle microflux. For some coagulant, alkalinity is a factor operators need to result validity for coagulation to be effective when using iron or aluminum coagulants that can consume alkalinity and decrease pH when they are added to low alkalinity water. And water temperature, for example, colder water usually slow coagulation and flocculation reaction which may require more time to achieve optimal floc formation. Extreme values of pH high or low will also interfere with the process. Coagulant effectiveness is highly dependent on pH. Turbidity is also important. The lower the turbidity, the more difficult it is to form proper flow. The most common coagulant chemical used is aluminum sulfate, commonly we call as alum. When added to water, alum forms jelly-like particles of aluminum hydroxide. Alum works Alum works best in a pH range of 5.5 to 7.5. Okay, maybe that's enough for me. And I'm sorry if I'm lacking for explain on this material. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. See ya.